Welcome back, everyone. Today we are going to be attempting to do something a little more interesting than the past videos. Rather than, doing the basics like multiplying, adding, subtracting matrices, today we are going to divide matrices or invert matrices or find the inverse of matrices. So let's get started. So let's set the title to Inverting Matrices. Just like that. Okay, so why don't we establish something pretty important like we usually do. So you have a matrix A. That matrix, in order to invert that matrix, it has to be a square matrix, and we've briefly discussed square matrices in the past, but again, just to specify this a little more, because this actually gets important now. If a square matrix is basically just a matrix where A and B are equal to each other in terms of the rows and the columns. So the amount of rows in a certain matrix must be equivalent to the amount of columns in the same matrix. So now that we've established that, let's just pick out a matrix first. I was going to say something today. I was going to say something else, but we'll get to that in a little bit. By the way, we're going to do a 2x2 matrix today, and later on we're going to do a little harder example of a 3x3 matrix. It's actually much harder, to be honest. And later on, I'll actually show you what matrices are good for, like solving a system of three equations and finding the solution for all of them on a two-dimensional plane. But anyway, that aside, let's just continue. So 2x2 matrix. Now let's spice it up a little bit. Let's do alpha again, like we did, if you remember, in one of the first few videos. So 2x2 matrix. And that will be, I gave myself too much space. I'm never good at this, anyway. So -8, why not? 4, 3, 6. So that is our 2x2 matrix. So now let's find we usually bold matrices, by the way. So what if we want to find the inverse of this matrix? Well, the inverse of any matrix A, let's make a broad definition of this. So let's pretend that a matrix A can equal any matrix. So the inverse of matrix A. So let's write it down here so I can have more room. The inverse of any matrix A is always this applies to, again, square matrices. Let's write this up here. Only applies to square matrices. Pardon my terrible handwriting. Anyway, let's write the formula. So it's essentially, let's write it in words first. So basically all it is just 1 over the determinant. I'll get to that. Determinant of the matrix multiplied by the matrix adjugate. Hopefully that's how you spell it. Look. So yeah, I'm only 12 years old. So as a result, I'm not very good at spelling. Or not necessarily. I'm not saying that 12-year-olds aren't good at spelling. I'm just not particularly talented when it comes to spelling as a 12-year-old. So, yeah, hopefully that's correct. It's probably not. Correct me in the comment section if you would like. So now let's write this formula in mathematical terms, if you will. 1 over the adjugate of A, sorry, the determinant of A, looks like the absolute value, I know, but this is also described as the determinant, multiplied by, let's assume that this is a 2 by 2 matrix in this case. Well, it's always like this, even for 3 by 3 matrices. We'll get to that later on. It can get kind of messy if I describe it right now. Don't worry, if you're confused, then don't worry. So D, A, negative C, negative B. So basically all the adjugate is just flipping over the terms here from, so usually this would be A and this would be D, of course, right? And you flip over these terms and you make these terms negative, but they stay in the same spot. Got it? Yep. It's pretty simple. And the determinant of A is, let's assume we have, we'll get to that once we're actually there in the formula, which is very soon. So let's take the inverse of this. So the inverse of alpha in this case, our matrix alpha, the inverse of this matrix, this 2 by 2 matrix, will be 1 over the determinant. The determinant is just these two terms, multiplying these two terms, multiply these two terms minus the product of these two terms. So sorry, the product of A, so the determinant, I don't know how, so the determinant of A, this can be broad definition of A, is equal to, in 2 by 2 matrix, is equal to A, D minus B, C. That's the determinant. So let's just apply this into our formula here. So negative 8 times 6, that is negative 48. Negative 48 minus, again, minus BC. 4 times 3 is 12. We'll simplify that later. Now let's take the adjugate of this. So flip these terms. That's 6, right, flipped. Negative 8. And multiply these two terms by negative 1, basically. Negative 4, negative 3. And that is our answer. We just have to simplify it now. So this is going to simplify to 1 over 60, negative 1 over 60. So this is simplified to negative over 60 times 6, negative 4, negative 3, and negative 8. Right, that's correct, isn't it? Okay, that is, I think. And now let's distribute, as you would usually do, distribute this negative 1 over 60 to all the terms in this matrix. Simple as that. So we'll simplify this in a little bit. 6 over 60, sorry, negative 6 over 60, positive 4 over 60, positive 3 over 60. Yeah, we can simplify this quite a bit. And positive 8 over 60. Right? Negative times negative is makes positive. So now let's simplify. Let's see how we can simplify this. Oh, I'm running out of room. 6 over 60 divided by 6, that's equal to negative 1 over 10. Right. Yep, just want to make sure that I got that correct. 4 over 60, that's should just be, yep, it's 1 over, yeah, 1 over 15, I think. Right, divided by 4, that's, yep, should be right. Okay, and then 3 divided by 60 is 20, so that's just 1 over 20. Wow, got quite lucky with the numbers here. I didn't actually pick this up prior to this video, but I got quite lucky with simplifying. the last one. So 4/30. Yeah, this can be further simplified. This is 2/15, and that's our entire simplification. So this is the answer. So theoretically, if you multiply this by this matrix, which we might do next video, you should get the identity matrix, which I will definitely introduce next video. It's quite crucial, actually, when it comes to inverting matrices. And I'll give you the intuition behind about how one in our real number or our natural number rules, like the inverse rules, identity rules in our natural numbers and real numbers. I'll show you how that's similar to the matrix or the matrix world, and this has a different definition in our modern day world with all the movies, but quite literally the mathematical matrix world. So thank you for watching today's video. See you next time, and hopefully this was actually quite interesting. In my opinion, it was more interesting than the past episodes. So thank you, everyone. Bye-bye.